What we know about our world comes from our observations, enhanced by technology. To better understand all the high-tech information available to us, we need to start at the beginning. It was obvious to this guy, Yuji, that anyone could see that the Earth is flat. So how do we go from Yuji's flat Earth to the title, a 3D map of the universe? We need to start at the beginning of man's quest, figuring out what kind of world we live in. From small family clans, in time, some of Yuji's relatives formed small city towns on the coast, built boats, traded by ship, and along the way made some great discoveries. Here is our cousin Giovanni, amongst others, who participated in these discoveries just by sailing around and around and around. All the sailing around changed our universe. We found that Earth is just a ball floating around in the center of our universe. No more flat Earth. So now we find man always seeking the new, creating a telescope, amongst other things. When we put that telescope in the hands of Galileo, that act changed our universe again. We were no longer in the center. We were just orbiting a minor star called the Sun. Okay, we lost our center, but learned that our Milky Way, crossing the night sky, was filled with stars, the home of our newly expanded universe. So in order to see the stars, we built these telescopes bigger and better. Here's the latest, the Hubble Space Telescope. Desiring to know as much as possible about our world, we focused our sights as far north as we could, some 12 to 13 billion light years away, and amazingly, we found 10,000 galaxies in this tiny limited northern view. Not satisfied with one picture, NASA aimed its telescope south and found a similar view, again some 12 to 13 billion light years away from Earth. Technology never sleeps. We progressed to include new satellites like this WMAP satellite in orbit that studies the cosmic microwave background called the CMB, allowing us to develop a 3D picture of the tiny color-coded ember radiations coming from 13.7 billion light years in every direction. This NASA picture, sliced open, finds Earth in the center of a center slice of a ball-shaped ember smoke ring that is flying away at near the speed of light due to the Big Bang explosion in space. Here we see that Big Bang that exploded in space, converting dark energy into matter. That explosion pushed out matter in all directions with unbelievable force. We note that Stanford Labs demonstrated this conversion of energy into matter in '97. During an explosion, usually the first stuff out moves the fastest, and those cooling embers are moving out at 99% of the speed of light that we sense as a CMB ember radiation. Because this first stuff out spreads like a smoke ring, it is too thin to form galaxies out at that 13.7 billion light year distance from Earth, shown here as a splotchy green edge of this explosive scene. As with all explosions, this explosive power diminishes rapidly, so that the next matter out goes at slower and slower speeds, at 90, 70, 60, 40, 20, until near the end, the last out is moving at less than 1% of light speed. This is where we find Earth, the Milky Way, and our local family of galaxies. We are just about the last stuff coming out of the Big Bang explosion. Earth's many measurements of the 0.2% equals about 375 miles per second. Pretty fast by Olympic standards. Super slow by galactic light speeds. Technology never stops. The latest evidence acquired by us in 2004 was that this WMAP satellite found a very unusual cold spot in the CMB ember sphere. It was finally reported 3 years later in 2007, giving us that third observation necessary for this 3D map described in our title. We need 3 spots to triangulate Earth on a celestial sphere. The coordinates of the deep fields and cold spot are available on the web for all to read. All we need to do now is plot and position them on any celestial sphere, as can be found on the web, like the one shown here, with declinations shown above and below the extension of our equator in space. And here the cold spot is plotted for us. Here is where we put NASA to work. We have the north deep field near the top at positive 62 degrees declination, the south deep field at the bottom negative 60 degrees, and Earth near the center, putting us approximately 12 plus billion light years from both fields. And last, the cold spot fixes Earth's location on this graph by triangulation, a common method of pinpointing cell phone locations with 3 antennas. Finally, here is that 3D map with the north field edge, center Earth, and across the south deep field, and the cold spot shooting off to the side, fixing Earth's position in the center, all in 3D. This changes our universe again from the time of Galileo. In conclusion, the last out of the Big Bang finds Earth right next to the center of our universe. And these cooling CMB embers are radiating from the edge. Thank you, ladies and gentlemen. This brings us to the end of Chapter 1. Look for more to come this year.